Okay, so the last talk I gave was really focused a lot on the scheduler and the system software based off of changing machine physical architecture. And this one I'm kind of
You
more
need to share
looking
your
at the,
screen again.
so this one is more focused on the storage system itself and how we can try to adapt how we're using storage to better manage a data-centric view of computing, taking advantage of container technology. Uh, as we all know, containers are really great for a lot of things. They've really infiltrated a lot of the compute space, and these are really a lot of the reasons why. Um, the things that I like about containers are really very different than what a lot of other people like about them. For me, I like the fact that you have a file system and a file, and that you have a unique hash code that identifies the container. Those are actually the two most interesting pieces about a container for me. But all these other things are what make them interesting for people when they are trying to do their compute in a wide variety of places. They can just move their container someplace else, and because all the dependencies come with it, they can run pretty much anywhere. And that's something that has been really a game changer for distributing compute to other areas. Um, the thing that I've done a lot of work in is this whole large scale storage area, and it's really great for handling these large write intensive kinds of jobs. We end up having very large parallel and distributed access. We get fast aggregate performance, and we have, for the most part, familiar interfaces. We could have something that has a key value store, for example, but that's really somewhat of superficial difference. Uh, the real thing that I want to focus on here is that when we're running all these containerized applications, what we have are standardized applications, but we're running against some generic data from somewhere. And it's generally from one of these large scale data stores somewhere. And if we want to be able to drive what we're doing based off of the data rather than the compute, we really need to be able to store the provenance about where the result comes from, and that includes not just the applications that it comes from, but also which data that it came from. And Provenance systems in general will store all of that information in a separate database, or there are some that actually store it as part of the system, but those are system specific things, and there's some limitations to those. And what they end up doing is they store references to things. For example, they'll have the path and file name of the executable that was used for the application. And that's marginally useful, in my opinion, because that is something unique to that system, and it doesn't give you something that is necessarily portable elsewhere, particularly if that gets overwritten later with a new version. So one of the examples of the system level storage driven provenance systems is called PASS. It's from many years ago, 14 in fact at this point. And what they did is that they extended the storage system so that it gathered all of the environmental information about whenever files were created or modified, and was able to maintain a database on the side that kept track of all that information. And in that sense, it actually is a really nice system. Problem is, it was really just a single node kind of thing, and it doesn't really offer a way to migrate that off of the system to a different one. So and one of the reasons for that is these hard-coded application paths. So if we look at this from, say, a containers perspective, we now have something that could be portable across different machines and allow that provenance actually to live and give us a way to be able to track back. So that's kind of the question I'm proposing here is why not look at this from a containers perspective? One of the things that exists in industry today are things that are called storage containers. Personally, I'm not a fan of the name because they don't actually, in general, offer storage, but instead they offer access to shared storage. And there are Singularity started, and I believe that Docker has it as well, an ability to create a container and then write to it and then have that persisted later. And that to me is more of what a storage container would be. Um, and what I want to be able to do is to have a way to take this provenance data that is stored in the provenance database by something like PASS, and then be able to move that along with the other containers so that we can maintain that information as we go forward. And The challenge there is that we'll need something like, actually, let me go back a slide here, like the storage containers in the old sense of them, because that offers a way for us to get interfaces into other kinds of storage, and we can do things in that interface to be able to give us what we want. So, for example, we could intercept all of the I/O calls by replacing all of our I/O primitives, and then be able to interface that with whatever provenance mechanism that we want. And that gives us the kind of thing that we'd really like to do. Um, so part of the challenges that we end up in trying to accomplish this is that containers really strongly rely on system installed device drivers. In working with the people from Scilabs with Singularity, they chose ext3 as their writable container format because that was the most advanced file system that they found was pretty reliably installed on Linux systems. They couldn't go to anything newer than that because they found that there were a significant enough number of systems without that driver installed that it just wouldn't work. And those are the kinds of things that can be challenging on this if we want to have a more robust storage format. Um, if we want to have additional interfaces that don't use that, then we have to have some sort of user intervention. And for example, I'd like to see if we can have a container that has one of these storage interfaces in it so that we don't have to have the system level device driver that ends up giving these kinds of functionalities. And probably the biggest question on this is how do we get from a single node to a massively parallel situation? And that's a question that still needs to be answered yet. That's actually a project that I have currently going on in a bit of a different context, but it works well in this right now. So a project that I did back last summer was called Data Pallets. And the idea there is you can see I have three different workflow pictures for what a single workflow component would be. The one on the left is what we would traditionally see where we have an application from some storage. It's going to pull the input data. There's going to be some input deck configuration, and it's going to do its processing and then push out to the next one. And then something that we could do with containers today is that we can put that input deck within a container, and we can put the application within a container and mount those together. And now we have unique handles to both the application and the input deck. What we can't do is this last picture, which is what the Data Pallets project was attempting to do, and that is have what I called a data pallet, which was a container full of data, and be able to send that in and then create on the fly additional ones, which would be the output coming out of that application workflow component, and then be able to track those because all of those would have unique handles. Um, the real bottom line problem there is that the way that containers work, the OS does not allow it because creating and mounting a container requires root level privileges. And unless we want to allow root level privileges, it's not something that's going to work. So what we did instead with data pallets, and this is a workable solution, is that we created it on shared storage and then packaged it up as a step after the application exit. Not ideal, but it was something that would work. So the way to really make this work well is that the one concept that exists currently that is separate from storage, but I think really should be part of storage, is to take your container repository where additional dependency containers get automatically pulled from, such as your Docker repo, and pulling that in and making it part of the file system so that all of the containers that you have are registered within the file system itself. And that way, when you try to take data and move it off system, you now have well, grab all of these other containers and take them along with it. And that would include something that included all of your provenance interface and provenance data as well. And that would be something that would give us a way to more drive our compute based off of the data and keep track of where the data came from rather than just the applications themselves and say, well, we processed some data to get this model. So this is ongoing work, but I wanted to share this idea to see if we could potentially drive some more interest in trying to push forward the idea of extending the storage system to include containers so that we can do these kinds of provenance kinds of things.
Thank you very much, Jay. Maybe there is a question, especially that you have presented us with very interesting prospects and ideas for how to deal with storage and how to use containers. I can't see People must be really tired now.
Yeah.
Well, if there are no questions to the speakers of last three talks, I still encourage you to think about it and maybe correspond with the authors, and definitely we will continue through private channels. Thank you very much, Jay, for your contribution, and thank you all the speakers of this session, Alex and Julian. Thank you.
Yeah. Thank you, Mark.